Choose the correct option for graphical representation of Boyle's law, which shows a graph of pressure versus volume of a gas of different temperatures. Now you see, when pressure increases, volume of the gas decreases. So when you plot the graph between pressure versus volume, pressure is inversely proportional to V. From this you will get PV equal to K constant, right? So it is not the graph of P versus 1 by V, it is the graph between P versus V. You will get the exponential curve, okay? So when P increases, V decreases, okay? When P is increases, V is decreases, okay? When P decreases, V increases. You will get like this, exponential curve you will get, okay? So which one has more in temperature? When you plot the graph at the constant temperature, you make this constant plot like this, right? Now you see, like this you will get, right? Now you see this in the this three intersection point, you see here P1 is there, okay? Here P2 is there, and here P3 is there. Now you see, as pressure increases, corresponding temperature value also increases. Yes or no? As temperature increases, corresponding pressure values also increases. Now which graph is correct one here? Your option D is matching. Okay, put a tick mark on. Choose the correct option for the total pressure in a mixture of 4 grams of oxygen and 2 grams of hydrogen confined in a total volume of 1 liter at 0 degrees Celsius, and given R value is how much here? 0.082 liter atmosphere per mole per Kelvin, and temperature value given here 273 Kelvin. Okay. Now by using the ideal gas equation we can find out the answer. PV equal to nRT. Total pressure, let us assume that is PT. V equal to nRT, N into RT. Total number of moles into R into T. Then how do you find this total number of moles? Total number of moles equal to number of moles of oxygen plus number of moles of hydrogen. What is the formula of number of moles? Weight by molecular weight. So weight of the oxygen given is how much here? 4 grams, right? Molecular weight of the oxygen is 32. Weight of the hydrogen given is how much here? 2. Okay, and molecular weight of the hydrogen is 2. So this is equal to 4 by 32 is 1 by 8, 2 by 2 is 1. 1 by 8 plus 1 is how much? That is equal to 9 by 8, and total number of moles equal to 9 by 8. And temperature already you know that is 273 Kelvin, and volume also they given, that is how much? 1 liter. Okay, then R value also they given. Just you substitute the values in this equation, right? So total pressure equal to volume is how much here? 1 liter, and total number of moles how much we got here? 9 by 8 into R value 0.08 I am taking, so there is 2 is there, so I am taking only 0.08 into temperature value is 273, 8 okay, 8 get cancelled, that is 0.01, so 9 into 0.01 is 0.09 into 273. Okay, 9 3 ja 27, 9 7 ja 63 plus 2 65, 9 2 ja 18 plus 6 24. After 2 digits you put point here. Approximately it is matching with 24.57, it is matching with 25.18. It is nearest value to 25.18. So your option is C. Then total pressure of the system is how much here? How much here? 24.57 atmosphere. Okay, so we can do like this. A mixture of nitrogen and argon gases in a cylinder contains 7 grams of nitrogen and 8 grams of argon. If the total pressure of the mixture of the gases in the cylinder is 27 bar, then find the partial pressure of nitrogen. Okay, and here given that a mixture of nitrogen and argon gas cylinder contains how many grams of nitrogen is there? 7 grams. And how many grams of argon is present? 8 grams. Then total pressure of the system is given is how much here? 27 bar. Okay, so use the Dalton's partial pressure of a gas. So partial pressure of any gas is equal to, total pressure of any gas is equal to mole fraction of that gas into total pressure. Okay, here gas means here you have to use nitrogen, so partial pressure of the nitrogen gas equal to mole fraction of the nitrogen gas into total pressure. Then how do you find the mole fraction of the nitrogen? Mole fraction of nitrogen, by using this formula we can find out. Mole fraction of nitrogen equal to number of moles of nitrogen by total number of moles. Number of moles of nitrogen plus number of moles of argon. Find out number of moles of nitrogen. And then how do you find this number of moles of nitrogen? Number of moles of nitrogen equal to weight of the nitrogen molecule by molecular weight of the nitrogen. What is the weight of the nitrogen given here? How much they given? 7 grams, right? Molecular weight of the nitrogen, here 2 nitrogens are there. Each nitrogen has 14 atomic weight. Molecular weight is 28. 7 by 28 is how much? 1 by 4. 1 by 4 value is 0.25. Okay. Similarly, you find the number of moles of argon. How do you find this number of moles of argon? Same formula. Weight of the argon by molecular weight of the argon. Weight of the argon given is how much here? How much? That is 8 grams. And molecular weight of the argon is how much? That is 40. 8 by 40 value is how much? That is equal to 1 by 5, which is equal to 0.20. Okay. Then how do you find the total number of moles? Total number of moles equal to number of moles of nitrogen plus number of moles of argon. Number of moles of nitrogen, how much here? This is 0.25 plus 0.20. Otherwise you directly take into this formula, which is equal to 0.45. Okay, now you substitute these values in this formula. Okay, then you will get the mole fraction of nitrogen. Mole fraction of nitrogen equal to number of moles of nitrogen is how much here? 0.25 by total number of moles is 0.45. Here also after 2 digits points are there. Here also after 2 digits we have a point, right? So you cut this points. So you will get here 25 by 45. Use 5 table. 5 5s are 25. 5 9s are 5 5s are 25. 5 9s are 45. Okay, mole fraction of nitrogen you got here 5 by 9. Now you substitute here. Mole fraction of nitrogen we got as how much here? 5 by 9. And total pressure is how much? Total pressure of the system is how much here? That is 27. Okay, 9 how many times? 3 times. So 5 into 3 is how much?
15.
5 into 3 is 15 bar. Your answer, which one is matching here?
B.
Answer B is matching. Is it clear everyone?
Yes.
Okay. A gas at 350 Kelvin and 15 bar has molar volume 20% smaller than that of an ideal gas under the same conditions. The correct option about the gas and its compressibility factor is, what is the formula for compressibility factor? Z equal to volume of real gas by volume of ideal gas. Okay, let us assume that volume of ideal gas is 100%. Okay, from this 20% of the gas is left, but from this 20% of the when you compare this real gas volume with ideal gas, how much it is smaller? 20% smaller than of ideal gas. So real gas volume is how much percentage smaller? 20%. Means 100 minus 20 how much? This will you get volume of real gas. So volume of ideal, from a volume of ideal gas, just you decrease this percentage 20%. 100 minus 20 is how much here? 80%. Okay, volume of real gas decreased to 80%. Okay. So let us assume volume of ideal gas is 100%. Okay. So this real gas volume decreases up to 20% when compared with the ideal gas value. Means 100 minus 20 is how much? 80%. So volume of real is, let us assume that is 80, and volume of ideal gas is 100 liters. Okay. Volume of ideal gas, let us assume 100 liters. In this 100 liter you just reduce the 20%. 100 in 20% means in 100 it is how much? 100 minus 20, the leftover is 80%. 80% means let us assume that is 80 liter. So 0 0 get cancelled. 8 by 10 is how much? That is 0.8. Is it equal to 1 or less than 1? This is less than 1. If Z value is less than 1, what are the forces are dominant forces? Attractive forces are more dominant compared to repulsive forces. So here which one is option matching here?
Option D.
Option D is matching. Because of attractive forces, the volume of real gases decreases. So here option D is matching.